end, I'm going to start that slide up right there. So again, like I said, nothing needs to be different in terms of the way we do this lesson. It's recording my voice, and it's only recording what's up on that screen. Okay. So yesterday we talked about concentration units that were percentage concentrations. We presented it as a ratio because that's kind of the easiest way in order to calculate it. Again, percentage concentrations are typically used to describe consumer items when it comes to solutions. But as chemists, we need the mole. Why? Because if we're going to do stoichiometry, we ultimately need to use a mole ratio, and therefore we have to have a concentration unit that then represents moles, okay? And that particular concentration unit is called molar concentration. The word molar is the same word that would pertain to the big teeth at the back of your mouth, like a molar, but this simply means pertaining to the mole. It's a molar-based concentration. It means that we are dealing with moles. So the equation, which again, because I've given you the note, is right there. There's no need to write anything down. Is C equals N over V. Now, this is an older note that I just keep using. In actual fact, we don't even need to worry about this letter M. I'll talk about what that letter M stands for. Well, it stands for molar concentration, okay? So when doing the equation and you're writing that equation out, you don't need to write C subscript M, but it kind of goes along with what we did yesterday where I wrote C percentage, right? We'll just write C. Yep. So C equals N over V. All right, C equals N over V. You can put it right on there. You can see I've already put it on the back of our chart paper there, which I had at the front of the class when we were learning about entities and we were learning about molar mass, and then we learned about the mole ratio. I've now put C equals N over V on our chart, all right? And I've got a little map that says it allows us to convert from moles to volume, like milliliters or liters, and volume back to moles. I will write that on the board in a moment when we get going. So C equals N over V, you'll notice it's got a subscript L here. That means that the unit must be in liters, but we are never going to write that down. So you can cross that out as well. When we get doing the calculations, C equals N over V. All right? Let's define these terms. We've seen N over and over again, and I hope you know what N stands for. What does N stand for? Clarissa, what does it stand for? Moles. Moles. V is the volume. This is the volume in liters. So in order to be defined as the molar concentration, it needs to be in liters. Now, it can be in milliliters under certain conditions, and I'll explain to you how. If we have moles divided by liters, we get a concentration in moles per liter. Moles over liters. Now, there's an old way in which this is expressed. The textbook will always say moles per liter, but you'll see in laboratories and various things that that is switched out for just a capital M. Now, that can be confusing because we've got M's everywhere. And when you see the capital M, it's simply called molar concentration. Whether you write the unit as moles per liter or capital M, I don't care. All right? Now, let's go back to the other units just for a moment. I need to have a unit of moles per liter. So I could have millimoles, all right? But if I have millimoles, then I don't use liters. I need something that has a milli in it so the millis can cancel out. So if I'm in millimoles, what volume must the unit, what unit must the volume be in? Milliliters. So I could use milliliters if I have millimoles, all right? Because if you think about it, millimoles divided by milliliters, the millis would cancel out, and I'd end up with moles per liter, okay? Normally, we're going to just go straight to liters, but there are some calculations that we're going to do in the future. Not today. Today, we'll just work in moles and liters. But there are calculations in the future that we can do where we can use this shortcut, and then we don't have to keep converting things all the time, because that's a pain sometimes. Okay. All right. So because I don't have it on the chart paper, you have it on your note. I'm just going to write it on the board. C equals N over V. We've got our units here. This is moles. This is liters. This is moles per liter, or M. Again, you guys are grade 11 university. You should be able to do math. But what would go on the top of my triangle if you're going to use that to do some rearranging? What would go on the top? Nope. Yep. The N. The thing that's on the top of the fraction goes there. All right? Okay? So if you need that, feel free to use it. Now at this point, I am just going to do a bunch of examples. And you don't have to write them down because they're on your piece of paper. It's the greatest thing ever. And that's okay. You might even know how to do some of these already. It's very straightforward. Determine the molar concentration if there's 0.232 moles of sodium chloride dissolved in 250 milliliters. The hardest thing in that question is to convert the 250 milliliters into liters. All right? C equal, I'm going to go with a white color because it stands out better. C equals N over V. Oh, and by the way, let's keep going. I was going to add something else. No, this is fine. We're just doing this question. Nothing special about it. I'm really hoping we're getting good at moles. Goes in for the N, right? 0.232 moles. How many liters is that? How many liters in it? If you're not sure, you could put just behind the 250 at times 10 to the minus 3, but you should be able to convert milliliters to liters. 0.25. It's a divide by 1,000, so we move it 3 to the left. 0.250 liters. 3 significant digits. What's the molar concentration? And for this video to, what do you got? 0.928. What units would you like to put with that? Anybody, I don't care whom. Yep. Capital M would be just acceptable. That would be molar concentration. If you wrote moles per liter, also correct. Doesn't make any difference. All right. Literally speaking, it means there's about 0.9 moles in every liter of that solution. Very straightforward. All right. Let's do another one. Okay, again, I keep forgetting I don't have to wait for you to write. So I can go straight into the explanation. This also is determine the molar concentration. Now, in various problems that are going to be more difficult than these, because these are the easiest, right? I'm introducing to you the concept. These are the easiest of easy. And the biggest trouble with answering chemistry questions, especially when we get to more complicated ones, is what do you do first? So when you're given a question that asks, what is the molar concentration? The first thing you should write down is C equals N over V. So when it says, what is the molar concentration? C equals N over V. Again, it's like the molar mass chanting like I've convinced you that that's the only thing. So C equals N over V. So the next thing we do once we've got the formula, C equals N over V, thank you, is we go looking for those things. which of those two things do I already have that's really easy to spot? Which of those two values of n over v do I have that, that we can fill in to the equation c equals n over v? Which of the two do I have? What? The volume. I have got the volume. And I can put that underneath. Excellent. So what I do is I go hunting for the things that I can find. What am I going to put on the bottom? What is 750 milliliters in liters? Yep. Looks like Julia is going to be 0.750, supplying us with lots of answers today. Oh, I'm just saying. Just put it out there. It's positive. It's a positive statement. Now, I need moles. What does the grams tell me? It tells me mass. What do I have to do? Yep. I need a molar mass. I need to use my other equation. I need to figure out moles. I put it into there, and then I do my calculation. So you can see, now we're going to use molar mass in conjunction with this. If I've got grams, I'm going to need molar mass of sodium hydroxide, and then I'm going to want an equation for moles. I need a formula for sodium hydroxide. And many of you are working away. What do you got? NaOH. And I see many of you head down, calculating away. Again, I need N. You've got your equation sheet. You should be able to figure out what the appropriate equation for N is. I'm going to write it in the corner. I'll put the triangle. We've got molar mass is equal to mass over moles. One, 16, 23, 40. N is equal to M over molar mass. Molar mass technically is capital M's, by the way, but I don't really care if you do it the other way around. 3.56 grams divided by 40 grams per mole. Somebody have a number they want to share? 0.089. That's it? That's all the calculators spit out? 90, which means it's exactly on it. Okay, moles. Now notice, you don't have to clear your calculator. That number should be sitting in your calculator, because we're going to take that number and we're going to divide it by that number. So very often, because we need moles in between these things, the one number will carry into the next calculation. If you happen to clear the calculator, if you've got the answer button, then that takes care of that as well. All right. What is our molar concentration for that one? I'm going to say L. What do you got? 0. Yep, I can see that. 119 moles per liter. I was just thinking that that's a small number, but that's less than 1. Makes good sense. I like it. Do I like it? Good? All right. So there we did 1, C equals N over V by itself. If we're given a mass, we've got to do a secondary calculation, but we're getting good at it. Okay. So now at this point, I'm just going to be throwing at you different types of questions, and it might be useful to come up with a plan on what to find in order to solve it. Now, I'm also setting you up for when we do stoichiometry. You know how we've got our map, and the map tells you what to do, and we did really good on that. So what I'm kind of lining you up here for is now a map. So the concentration C, is very much like a molar mass, all right? It's even in the same position in the triangle as molar mass, all right? It means that if I know the concentration C, then I can either take the moles and find the volume, or I can take the volume and find the moles. And so concentration, yes, we can calculate it, but it's also something that can be used to find moles or volume. On my chart at the back, I wrote that down like the map that we had up above. Notice I put the C above the arrows because it's the thing that allows us to go back and forth. So if I get a question like this that says, how many moles? I'm trying to find moles. I'm given the volume. 350 milliliters. How do I get from milliliters or volume to moles? I need the concentration. So the concentration is like a molar mass. It allows me to find volume or moles depending on what I'm given. But it's slightly different than molar mass. Notice in the question, I have to tell you what the concentration is. I have to tell you that it's 1.3 moles per liter. 1.3 moles per liter. Okay. Now, let me just talk a little bit about why that's different. A molar mass depends on what the identity of the chemical is. If it's sodium hydroxide, I need the formula of sodium hydroxide. I use my periodic table, I get the molar mass. But the concentration of a solution in a jug is not dependent on what the substance is. It's dependent on the scientist who made the solution. So if I'm making a solution for you in a laboratory, then I'm going to take so many grams and I'm going to dissolve it up. And then if I need you to do a calculation to figure out how many moles, I need to tell you how strong I made that. I write it on the side of the jug, 1.3 moles per liter, and then you know how to do the calculation for that solution. If I create a second solution, maybe with the same chemical in it, maybe it's both sodium hydroxide, but this time I make it stronger, 2.6 moles per liter, then if you use that solution, you've got to use the different concentration in order to do the calculation. So you need to be told the concentration in order to use that like the molar mass. Where molar mass, all you need to know is what the substance is so you could get the formula. All right, so now we've got everything here. We've got the volume. We want the moles. Yes, we can pick the equation out at this point. What will it be when I rearrange that in order to get that equation? What's it going to be? N equals, yep, C times V. C times V. And it is 1.3, capital M is fine, times, what do I have to put in here for that volume? 0.35, 0.35 liters, because that's in moles per liter. And how many moles is in that little bit of liquid? Yep. 0.455, 0.455 moles. Okay? Now, because you don't have to write it down, some of you dove right into that particular equation. You didn't think about all this blah, blah, blah that I told you. You pulled it out and you got it right. And that's fine. That's good. But it is useful to think about how these numbers behave. All right? Notice the unit for mole, for molar mass. Grams per mole. It's got both grams and moles in it. That allows you to put it in the equation and figure out grams or moles. Just like my unit for concentration, moles per liter. That's going to allow me to go back and forth from moles to liters. Okay. And again, I'm kind of setting you up for when we do stoichiometry, how to think. Ignore the children going by the door. All right. Again, it's a little overkill, so I'm not going to draw the math, but I'm looking for a volume. I've got the moles and I've got the concentration. Again, I have to be told that concentration, depends on who makes it. And now we're looking for V. You're picking the equation, you're putting the stuff in. If you want to rewrite this as moles per liter, you can, but you don't have to. Totally up to you. Picking the appropriate equation. I'm hoping we know that this is N over C. That's a typical one that people make mistakes on. I don't know why they get it flipped over. N is 0.37 moles. C is 0.90 moles per liter. What is the volume of that solution there? Yep. 0.42, and there's only 2 decimals there. Or 2 digits there. I like that. What's the unit? It's liters. It's liters. What if we needed that in milliliters? Not that it doesn't say what unit to put it in, but it is useful to be able to convert back and forth. How many milliliters would that be if we went back the other way? Clarissa, what are you thinking? 420 is correct. 420 milliliters. That's not part of that question, but sometimes we need a milliliters for some reason. And it's useful to be able to go 3 one way or 3 the other way. All right. Now, I really hope, I checked my microphone earlier on to make sure that it was working. If when I check this video, there's no sound and the microphone doesn't work, I'm going to teach the whole lesson over again. I don't know, I will do that. I'll figure out what to do. And I want the same people to give the answers. What's that?
When you're here productive, you have to like keep talking to people.
I've made many videos by myself talking to empty classrooms. I have. I'd put a sticker on the door that says recording in process. Especially during the dark times. There was a lot of me standing in this room, not even doing online stuff, just speaking to this microphone. Okay, what mass of silver nitrate is needed to make an 850 milliliter solution of 0.12 molar solution? Okay, so we have to start thinking like chemists. When it asks for what mass, what are we really looking for first? When it asks for what mass, in your brain right away, you should be thinking, I need to find this, moles, because we can always go from moles to mass with a molar mass. So when it says what mass, I first find moles, and then I know an easy way to get to there using the molar mass. And that's a good way to think. Again, as you guys start to be mature chemists, what mass? I need moles first. If I were to make a big map of this, and some of you are already calculating away, and that's great, but if you want to see a little map of it, what mass? We want to find the grams. We're starting with a volume, 850 milliliters. I don't have an equation that goes straight there, but I can get moles through that concentration unit, right? Because remember that concentration unit has the moles per liter. And then once I have moles, I can get it through the molar mass. That might be more confusing than what needs to be in this question. Like I said, if you think, oh, I need moles first, then I'll use my equation to get moles, and then I'll get the mass. N equals, and you guys are getting good at this, which is good, C times V. I'm going to get a number there. And then I'm going to have an M, and I need a silver nitrate. And I will pause for you to calculate. And I will catch up. I need a 0.12 molar, 0.850 liters. Formula for silver nitrate. That's not silver nitrate. That's silver nitride. So you've got to find the nitrate. It's an NO3 minus 1 What do you got? AgNO3. And I am not going to drag that all out. Do you have a molar mass of silver nitrate? 170, 170 grams per mole. And it's not that I don't trust you, but do we like it? Okay, we like it. All right. What am I doing? Mass, it's going to be, it's going to be MM times N. Oh, I need an N. Somebody got an N? Got an N? 102 moles, 170 grams, 0.102 moles. Sorry, that's grams per mole. Grams per mole. Mass. 17 point, to 3 digits would be just 17.3, which is good. Grams. All right. So if we took our scale and weighed out 17.3 grams on a nice piece of weigh paper, or maybe right in the beaker, and then we filled it and we dissolved it until it got to a volume of 850, we would have created our silver nitrate solution. Okay? Couple more. So this one's in reverse. See, the reason I did the big speech on the C, all right, is that the C is never really the starting thing of my calculation. If I'm given a concentration in moles per liter or molarity, then that's not my starting point in the question. That's just something that's going to be really useful in doing the question. So in this case, I'm starting with a mass. I'm starting with 5.5 grams, and I want to eventually get to volume. And this is where sometimes a little map can be useful. Mass to moles with the molar mass, and then we continue on. Mass to moles, molar mass, and then moles to volume using that C that we were given. We're doing lots of calculations again with moles and things, yet this isn't stoichiometry. We're going to do stoichiometry later on, but how would you know that this isn't stoichiometry? What does a question have to be about to be a stoichiometry question? Yep. That's true. There has to be a mole ratio involved. Where do we get the mole ratio? What has to be happening in a question? What's that? We need a balanced equation, which means there must be a chemical reaction taking place. So there are words like reacts with or produces this. Notice in here, we have no words like that. It's just what volume, one substance, sodium hydroxide, and a mass. There's nothing reacting with something else. So in this case, we don't need a balanced chemical equation. We just need to think about what equations to use. All right, and I'm going to catch up to you guys. We've already done an NaOH, I believe. That's a 40 grams per mole. I'm looking for moles. N equals, I need to write it down sometimes, M over MM, I believe. Let me know if I'm screwing it up. Be bad on my video if I'm screwing it up. 40 grams per mole. We'll take that N over there. I'm looking for volume. V equals N over C. Notice how the N from here goes into the top of this, which means you don't have to press the clear button. You can just divide it off, and we will get the volume that we could make. Does somebody have an N number they'd like to share? 0.137. Julia's giving all the answers so that she can play the video at home, maybe for a parent, saying, look at how much I participate in class. That's good thinking. I know what you're doing. That's just so much fun. 0.137 moles divided by the concentration, 1.50. Again, you can change it to moles per liter. You can leave it as molarity. What's the volume? Got the volume? Not a big deal. You got a number? What do you got?
92.
92? Ooh, 92. This...
I had mine was 1.128. So there's 0.
So you've got 0.138, 0.138, but if I have a 0.1 divided by a 1.5, see how that's a tiny number over a big number? You shouldn't get a number like 92. I think you have it upside down. I think you put in 1.5 divided by by something. What do we get? 0.092. So you had 92. So I'm not sure what happened there. 0.092. 2 digits is good. 2 digits is good. What's the unit on that V? What is the unit? Oh, what do we measure our volumes in? Liters. 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 Did you figure out what you did?
No.
Okay. Again, I blame the nails. I've got scissors that could take care of that. Like if you just took one off, it could be your calculator button pushing finger. Okay, let's do one more. Let's do one more. Okay. What's the matter? What's wrong? Oh, this is a fun question. This links together what we did yesterday to today. Like I said yesterday, if I were to go out and buy some, let's say hydrogen peroxide, 3%, W/V or V/V. W/V is easier. That's what we're going to work with here. Hey, listen. Is there a way in which we can convert that to moles per liter? And the answer is yes. So, is everybody paying attention? Are you distracted by the children outside? Do you want me to stick my head out the door and like scream at them and make them leave? Yeah. They're doing a scavenger hunt and they're running around like maniacs. Like it's absolute chaos. I can't do that too early, right? I only do that when you get to grade 11 and you don't behave well. Then I yell. No, I'm not going to do it. Let us proceed. Let us refocus. Are we refocused?
No.
Well, focus on me. Focus on me. Yes. Nope, stop. I'm not playing that game. Let's finish this so that you guys can do your problems and be done with this and get your homework done. Okay. Notice it says determine the molar concentration. Ignore them. I told you that when you get a question that says determine the molar concentration, write this down. What should you write down? C equals N over V, right? And then go looking for that information. C equals N over V. Okay. Yesterday I told you what 15% W/V stands for. Let's write that down. If I were to write that as the left side of that percentage calculation, what would I be writing? Yep. Now the units become very important. 15 grams per 100 milliliters. That's going to contain all the information we need in order to complete this. What's the volume of the solution in this case? What's the volume of the solution in this case? Nope, that's not a volume number. 100 milliliters. So I can put that in for V, right? That's the volume of the solution. I can put in here 100 milliliters. I don't put it in as 100 milliliters. What am I writing? 0.1. 0.100 liters. Now I need N. But I have this. What am I going to have to do? What do I have to do? I need a molar mass, turn it into moles, put it on top. I've used sodium hydroxide again. We know the molar mass of sodium hydroxide. No need to recalculate that. We'll do our calculation, get the number of moles in 15 grams, put it in, and we will have converted it into a molar concentration. NaOH 40 grams per mole, and equals, that one, I have to truly visualize the equation. N is equal to molar mass times moles. Times mass. No. Mass over molar mass. Whew. Struggling. 15, 40. Every fiber of my being wants to go out and scream at those children. I would get into so much trouble. I would. Nope. I'm holding it together here. I'm holding it together. How many moles is this? Sorry? 0.375 moles. 0.375 moles. I'm going to lose it. I'm going to lose it out there. Too much chaos. All right. Concentration. Yeah, what do you got? 3.75 moles per liter. All right. So you can see on the bottom of that slide, there's lots of textbook work. And there's also the worksheet that I gave you yesterday. There's a mistake in one of the answers, I think, on the worksheet. Same stuff. If you're all gunning for going to the bathroom, it would be irresponsible of me to let you go out there right now. It's unsafe. It is unsafe. Oh, I can stop my video first. All right. I hope it's good.